Find all the zeros given a 0. Step 1, we want to plug it in our calculator and see what we see. You'll notice the given 0 was negative 2i, and because we know that imaginary numbers and complex numbers come in pairs, we also know another 0 is positive 2i. Let's see if we can find any easy zeros in our calculator to use. So plug it in, let's graph it. It does look like we have 3 real zeros. Let's see if they're rational or something that we can easily find. So let's go to our table and, well, let's identify. It looks a little less than negative 2, and if I zoom in a bit, maybe I can kind of tell where the next one is. Okay, so this one looks like it's probably a fraction, but maybe there's one right there at positive 2. So second table, let's go look and see if there's one at positive 2. There is. Okay, so we have one at positive 2, and we know 2 others. So let's write down the positive 2. So we know that 1 0 is negative 2i. We know that definitely has a pair, so that's positive 2i as well. And then we have one that we found in our calculator that's positive 2. We weren't able to come up with enough to get all the way to our degree, which is 5, so we're going to have to do a little work. We can use synthetic division with 2, but we can't really use synthetic division with negative 2i and positive 2i. But what we could do is we could multiply those factors together and get a polynomial and use long division. You wondered why we went over long division at the beginning. Well, this is it. So if we have 2 imaginary zeros, we can always multiply those together. So let's turn them into factors. So this is x plus 2i times x minus 2i. And we could multiply that one in, or we could do synthetic division later. It doesn't really matter. Since we're going to do long division, I would probably just go ahead and multiply it as well, but I would do it one at a time. So let's multiply these two together, and we're going to say x times x is x squared. You might notice that this is the factored form of a difference between 2 squares, but if you don't, no problem. Go ahead and multiply it out. X times x, x squared. X times negative 2i is negative 2xi. 2i times x is plus 2xi. And 2 times negative 2 is negative 4. And I times I is I squared. Now when we clean all this up, these are going to cancel out, and we end up with x squared. If you remember, I squared equals negative 1. So we're going to replace that I squared with a negative 1. Negative 1 times negative 4 is positive 4, which makes sense, because if we set that equal to 0 and solve, we'd have x squared equals negative 4, which would cause us to get positive and negative 2i. So here's one factor. Now we can't use synthetic division with this because it is not a linear factor. Here is another factor. So this is x minus 2. Since we're going to have to do long division, we might as well multiply this out as well. So let's go ahead and do that. So x squared times x is x cubed, and x squared times negative 2 is negative 2x squared. 4 times x is plus 4x, and 4 times negative 2 is negative 8. So this right here is what I'm going to divide this polynomial over here by. And so we're going to use polynomial long division, and let's go ahead and set that up. So on the outside, I'm going to put this polynomial right here because I'm going to divide my original polynomial by, this is a factor, and see what the other portion is. So x cubed minus 2x squared plus 4x minus 8. We're going to divide that into this long polynomial right here. X to the 5th minus 2x to the 4th plus x cubed minus 2x squared minus 12x plus 24. So I apologize. I'm getting kind of close to my other work. All right. Let's hopefully we remember polynomial long division. We want to look at the first term on the outside and ask ourselves, what do we multiply that by to get the first term on the inside? So x cubed times x squared will give me x to the 5th. So x squared times x cubed is x to the 5th. X squared times negative 2x is negative 2x to the 4th minus 2x to the 4th. X squared times 4x is positive 4x cubed, so plus 4x cubed. X squared times negative 8 is negative 8x squared. Now once I multiply that through, I draw the line and change my signs. So all of my signs will change, and that way I can just add down. My first term cancels out. And look, my second term cancels out. Third term, I end up with negative 3x cubed. Negative 2x squared plus 8x squared is plus 6x squared. And I'm going to bring everything else down. So minus 12x plus 24. All right, now I repeat. What do I multiply by the first term on the outside to get my new first term on the inside? And so it's negative 3 minus 3. Negative 3 times x cubed is negative 3x cubed. Negative 3 times negative 2x squared is positive 6x squared. Negative 3 times positive 4 is negative 12x. And negative 3 times negative 8 is positive 24. Now I'm going to draw my, you might notice they're lining up perfectly, but we're still going to do it just to make sure. Draw our lines and change our signs, and then we're going to add down. Cancel, 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 cancel. Our remainder is 0. So that means that this right here is a factor. So if I multiply that by this, I should get my original function. Now, how did I get this? All of these factors multiplied together. So I have 1 0, 2 zeros. I multiplied those together. 3 zeros, and I'm hoping that I can find my last 2 here. So let's come back over here and let's find the rest of these factors. So x squared minus 3 equals 0, or x squared equals 3. And we're going to take the square root of both sides. So we end up with x equals positive or negative square root of 3. The reason that we couldn't find it on our calculator is because it's irrational. We saw it crossing the line, but we couldn't figure out what it was. Okay, so how many zeros should we have? We should have 5. Let's list them for our final answer. X equals. Now they gave us negative 2i, which means we know we have positive 2i. We found in our calculator positive 2. We multiplied all 3 of those factors together and used long division to find this final quadratic, and we solved it for positive square root of 3 and negative square root of 3. So we ended up finding 1, 2, 3, 4, 5 zeros for a 5th degree polynomial.